In 1990, as the tower was continuing to move at a rate of roughly 1.2 millimeters a year, so that its lean was becoming more and more dangerous every day, the Italian government decided to set up an international committee to care for the most famous bell tower in the world. The International Committee was composed of scientists and scholars of many different disciplines. For 10 years, they devoted themselves to seeking the most appropriate solutions that would safeguard a monument which, together with the entire Piazza dei Miracoli, has been declared a World Heritage Site by UNESCO. The experts immediately realized that the tower was in serious risk of collapsing, partly as a result of the nature of the ground on which it rests, composed of marine and river sediment and therefore highly deformable, and also because of the stress it was subjected to by the lean itself. In addition, even though it was a situation of maximum alert, attention also had to focus on the severe deterioration of the stone surfaces. By analysing the structure of the tower, the experts discovered there was a very serious risk of breakage at the first level, at the height of the first order of columns, the area most greatly stressed by the lean. The probability of collapse was extremely high, and so it was necessary to act immediately by taking urgent preventive measures. Therefore, an encircling support structure was created to run all the way round the first order. Several steel cables with a 15mm diameter, insulated by a special sheath in order to protect the marble, were positioned around the first order, so as to counteract the widening of the cracks and ensure that the masonry remained compact. At the same time, the committee undertook temporary works aiming to prevent the lean from continuing to increase. So in 1993, a series of weights were applied north of the monument to counterbalance the lean. On the northern part of the basin, a circular beam was constructed to support the weights. The girder, made of pre-stressed reinforced concrete, was carefully separated from the marble walls of the tower by means of several layers of insulating material. Work on setting the girder and the supports in place was carried out between July 1993 and February 1994. 60 ingots of lead, each weighing 10 tons, were positioned along the circular girder at suitable intervals of time. To ensure the tower would not come into direct contact with the weights, its surface was protected with a layer of rubbery material that was placed over Teflon sheeting. These measures guaranteed that the tower became temporarily safe so that further studies could be performed without any imminent danger. A complex monitoring system was installed, capable of logging up to 220 different signals every 5 minutes. Meanwhile, dozens of experiments were performed to analyse the behaviour of the tower in the main risk conditions. For example, to test its wind resistance, a model on a 1 to 200 scale was built, composed of the bell tower and all the surrounding buildings, extending over a radius of 600 metres. The model was then tested in a special aerodynamic wind tunnel. Once the lead ingots were in place, scientists observed that for the very first time in its history, the tower's headlong tilt southwards actually stopped, and in fact its lean even decreased by 1 centimetre. The favourable outcome of this temporary work led the committee to design measures that would obtain the same beneficial effect as the counterweights, but would eliminate the unacceptable visual impact of the ingots piled up against the northern wall of the tower. The committee drew up plans to replace the load composed of lead ingots with a system of deep anchorage up to a depth of 45 metres. The anchored weights were fixed to a buried reinforced concrete circular girder cast around the foundations of the building and forming a hole together with the foundations. No problems were encountered in setting up the girder on the northern side. But when the decision was taken to start work on the southern and eastern sides, the experts found themselves facing such a dire predicament that work had to be suspended immediately. What had happened was that in order to complete the installation of the ring-like girder on the southern side, in September 1995 it turned out to be necessary to freeze the ground by injection of liquid nitrogen. Suddenly, the situation became dramatic. The tower rebelled and began to tilt sharply. To avert the threat of imminent collapse, another 270 tons of lead had to be set in place to the north of the monument, and the anchoring project had to be abandoned. After the danger had been forestalled, the committee drew up a new project which would prove a great success: the controlled removal of soil. The idea was that by extracting small quantities of earth, the soil would settle slightly so that the tower would be induced to incline just a little towards the northern side, counterbalancing the lean towards the south. Before proceeding to soil excavation, the scientists decided to embark on a large-scale test a few dozen meters away from the tower. They also undertook the creation of a guy wire, in other words a sort of lasso wrapped around the tower, ready to support it at the first warning signs. In 1998, once the test had given positive results, two roughly 100-metre steel guy wires were constructed, connected to two anchoring structures that would be able to tighten the cables and ensure they were kept taut. Ready to spring into action at lightning speed in any emergency, the system of steel stays never had to be brought into use. Between 1998 and 1999, the masonry was consolidated in the critical areas through injection of a specially created mortar, chemically compatible with the original materials, and insertion of slender stainless steel bars. The first excavation work started. 12 drills were utilised, and over a period of 6 months they removed about 7 cubic metres of earth, slightly decreasing the inclination. Given the excellent results, work continued with the definitive excavation. 41 drills gradually removed 38 cubic metres of earth. Meanwhile, the lead weights were taken away, as they had by now fulfilled their stabilising function. The ring around the bottom of the basin was removed. The drills were dismantled. The guy wires were disassembled. And finally the tower, as if it had turned the clock back by 2 centuries, had recovered that vital half a degree considered crucial for long-lasting stability. And now it could be open to the public again. It was the year 2001. The leaning tower has been saved without hardly having been touched. But the tower still has a long way to go to complete recovery. Now that the tower is once more out of danger, the next step to be undertaken is restoration of the surfaces.